All right, and then here's problem 5 off the final exam for spring 16, Math 213. This was a pretty challenging problem. We're dealing with isometries here. What's going on is I started you out with this triangle here, A, B, C, and I transformed it 4 different times to give me 4 different triangles here. And what you first want to do are label the vertices A prime, B prime, and C prime of each of these different triangles to figure out which is which. And so I think the easiest way to do that is to note that there's one vertex that's furthest away from A and C. Just by inspection, I can tell that B is far from A and C. And so it's pretty easy to find that guy on each of these. Here's B prime, here's B prime, here's B prime, and here's B prime. But what's harder is figuring out which one is A and which one is C, because these angles look really similar. This one's a little bit smaller, so if you're really good at looking at these, you might be able to tell which one's smaller. But I think an easier way to get there is thinking about the length of these guys. The distance from A to B is 1, 2, over 3, up 1. The distance from B to C is up 3 over 2. So what I'm saying is AB is shorter than BC. AB up 1 and over 3. If I could figure out a point that is that distance from B, I would know it must be A. Well, note that if I go up 1 here, and then over 1, 2, 3, I get to this point. So this must be A prime. And from this guy, if I go down 1 and over 3, I get to this point. So that must be A prime. And then over here, from this point, if I go up 3 and over 1, I get to this point. And finally, from here, up 3 over 1, I get to this point. And so by process of elimination, the remaining vertices must all be C primes. Okay, so now what I'm supposed to do is find the translation, that's T1, and find the rotation, that's T2. Translations and rotations have a nice property to them. They preserve orientation. So this original triangle, if I read the vertices, I don't know, clockwise, why not? They go A, B, C. If I read it going around in a circle like this. If I read these going around in a circle, A, B, C, they preserve orientation as well. If you read these going around in a circle, it's A, C, B. This is not one of my answers. If you read this going around in a circle, it's A, C, B. The orientation there is also not preserved, so it's also not one of my answers. So these are my 2 answers. One of these is a translation, one is a rotation. The translation will kind of preserve direction. So note that the B is sort of pointing up and to the right here. Similarly here, this must be my translation. There's T1. The rotation will be preserve orientation, but not preserve the direction. So it kind of gets rotated down like this. This one over here must be T2. One of the isometries is a translation. Label that triangle T1, then sketch the image of the point 1, -3 under this same translation. So this translation, I can think about what it did to each of the points. It took A, if I just pick any vertex, it took A and moved it up 1, 2, 3, 4, 5, and then over 1, 2, 3, 4, 5, 6, 7. So T1 moves up 5, and then right 7. And what I'm supposed to do is apply that transformation T1 to the point 1, -3. So 1, and then down 1, 2, 3 is this point. So this point, did it give me a name for it? Nope, it just said a point. It needs to be transformed. So maybe I'll call this P or something. I'm going to take P and I'm going to transform it by moving it up 5. 1, 2, 3, 4, 5. And then to the right by 7. 1, 2, 3, 4, 5, 6, 7. And this would be P prime, the image of this point P under this translation. And I'm still not done, because then it said one of the isometries is a rotation. Yeah, that's T2, I knew that. Label the center of rotation and the angle of rotation for this isometry. So the way you do that is you connect corresponding vertices. So maybe we'll connect A and A prime. And then draw the perpendicular bisector. And really not draw, but construct. So I'm going to try my best to construct that. I don't think I need to show you how to construct a perpendicular bisector, although I'm doing a pretty poor job of even approximating it. Something like that. You can spend more time coming up with that. And then connect any 2 other guys. I don't know, C and C prime maybe. Connect these guys. And I want to draw that perpendicular. Well, that's really hard to see. Maybe I'll try B and B prime. Maybe that'll be easier to do. There's B and B prime. And if I draw the perpendicular bisector of that guy, oh, maybe it looks something like that. This would be my center of rotation. And this would be my angle of rotation. Here. I think I've done everything. So I guess I can move on from this problem. I think I'm going to keep it in the same video because it's still question number 5. Question number 5 asks you to talk about these two guys. It says one of these guys is a reflection, one's a glide reflection, and kind of deal with those. One of the isometries is a reflection. Is this guy a reflection or is this guy a reflection? Well, I think you can just sort of see it. This guy, if I reflected over a line something like this, maybe I should label the vertices again. This was A prime, and this was C prime, and this was B prime. Maybe you can kind of see that there's a line in here that I could flip this over and it would land on it. This will end up being the reflection. There's not a line where you could do that for this guy. This is B prime, and what did I say? A prime was the bottom, and C prime was up here. So this one must be my glide reflection, so it's T4. So label T3, then sketch the axis of reflection and calculate the slope of that line. Okay, so the axis of reflection will go through the midpoint of corresponding vertices. So the point halfway between C and C prime is exactly this guy. Now to get from C to C prime, I go over 2 and down 2. So if I go over 1 and down 1, I hit this point. What about A to A prime? Well, I go over 1, 2, 3, and down 1, 2, 3. So the midpoint, I'd go over 1.5 and down 1.5. I'll get this point right here. If I connect those points with a straight line, that's not really a straight line, but maybe you'll let that slide. I can figure out the equation of that line. Well, to figure out the equation of a line, I need to know the m and the b. The m is the slope. The slope is how far it goes down every time it goes over. Looks like this. It's how far it goes up every time it goes 1 unit to the right. So this one goes up by -1, aka down 1, when it goes to the right one. In other words, the slope is -1 divided by 1. Maybe I can write that over here, which is just -1. So y equals -1x, or just -x, plus the y-intercept. Well, the y-intercept is right here. That happens at -1, 2, 3, 4. So b equals -4. So I get -1x minus 4, or y equals -x minus 4. This is the equation of the line of reflection. Finally, one of the isometries is a glide reflection. Label that triangle T4 and sketch where this isometry would take the triangle T1. I think I might have changed that problem on the test. I think I did it something that was slightly easier because this problem was getting a little bit overboard. But since that's what it says on here, I'll just go ahead and do that one. So what I want to do is first figure out the axis of, well, there's a few ways you can do this. I wonder what would be easiest. I'm going to do it the way you're supposed to do it. Okay, so first find the axis of symmetry. So I need the midpoint between B and B prime. What I get from B to B prime, I go up 1, 2, 3, 4, and over 1, 2, 3. So the midpoint would be up 2 and over 1.5. Here's the midpoint between B and B prime. From A to A prime, I go up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4. So for the midpoint, I would go up 3 and over 2, 1, 2, 3, over 1, 2. And I get here. Turns out that my axis of reflection is just a horizontal line. So what this glide reflection does is it reflects these points over this line. This B, which used to be 2 points below this line, is now 2 points above this line. And this A, which used to be 1, 2, 3 points below, is now 1, 2, 3 points above. And this C, which used to be 1, 2, 3, 4, 5 below, is 1, 2, 3, 4, 5 above. So I kind of go to here. So what's going on is I reflect over this line, and then I translate 3 to the left. So the glide reflection, I reflect over this line, and then I translate 3 to the left. Glide reflections translation is left 3. So the question that's asked is, what would happen if I did that to T1? Well, here's T1. If I reflected it over this line, this point would stay here. This point would go down here. And this point, which is now 3 above, would be 3 below. I'd get this triangle, but that wouldn't be my final answer because I still need to shift that guy 3 to the left. So this goes 1, 2, 3. This goes 1, 2, 3. And this goes 1, 2, 3. And so this would be the image of T1 under that glide reflection. I don't know. Answer. This is answer to part 4. Wow, yeah, that was a pretty hard problem. I think I ended up giving a lot of partial credit on this thing, showing what you know about the different translations.